All right, we get going?
Give me 1 second.
Okay. All right, good evening, everyone. Oh, you guys can do better than that, come on. One of the old jokes back at work was, there's plenty of seats up front.
Do you have the mic?
Oh yeah, it's right here.
Yeah.
So, all right, so, all right, it's summertime and everybody's getting all giddy and everything. Anyway, so welcome to the July 2023 edition of the Garden State Java User Group meeting. And we have lots of great stuff for you tonight. And so I'll get my usual spiel out of the way and then I can introduce Frank. So, there we go. As usual, our agenda will be, we'll thank all of our sponsors, talk a little bit about what's new going on in the Java community. I'll introduce Frank, and then he'll do his presentation. And at the end, we just do a couple of things. What you can expect from other Java groups, what we're planning for you in the next few months. And then, of course, we'll have our giveaway of IntelliJ IDEA, thanks to JetBrains. All right, so our platinum sponsor, thank you very much to JFrog, the DevOps company. So they've been very, very supportive, ever since the beginning, and we appreciate all the support they give us. Ari Waller is one of our advisors, so he does, they do meet with us and tell us how we can improve, and we tell them what we've been doing and all that good stuff. So Azul is our silver sponsor. Okay, and they have their downstream distribution of OpenJDK, which now actually supports the coordinated restore and checkpoint crack. So, so that's something new that's been going on with them. DevNexus is our partner, and this is, I've heard from a number of folks, becoming the new Java 1. And it is a very popular conference, and I'm going to try to get out there myself for the first time next year. So it takes place in Atlanta, and it's usually in the March-April timeframe. Our per meeting sponsors are JetBrains. They provide us the licenses every month for IntelliJ IDEA, and Eclipse Foundation and Jakarta EE. They provide video conferencing hosting that we've used in the past, but they offer this to all Java user groups around the country. All right, so what's new? So the latest is Java 21. It will be coming out in September. I think it's September 19th is the formal date. There are 15 JDK enhancement proposals, or JEPs, and you can see them right there. You may be scratching your head and say, hey, Mike, what happened to JEP 404, which is generational Shenandoah? Well, the big surprise was that the team who put that together felt as if they weren't 100% ready, so they actually withdrew from being included in JDK 21. That'll probably, they're shooting for JDK 22, which will be in March of next year. But this is a whole list. A lot of these features are final now, like virtual threads, pattern matching for switch, record patterns. These have all gone through their iterations of preview or incubation. You'll still see a couple that are in that mode, like scope values, vector API, and so on. So you can look forward to those progressing along over the next releases of JDK. Also, too, real quick, is a collaboration between the microprofile working group and the Jakarta EE working group, working on Jakarta security being able to utilize the JSON Web Token that's offered by microprofile. And this is be able to avoid having, copying the specification over in the Jakarta EE side. So there is in the process a community naming for this. A few names have been recommended. So we're going through that right now. And it's been decided that this new specification will be in the microprofile set of specs that are standalone. So it's not part of their core. So that's what's coming on there. So look for that later this year. All right. So I've spoken enough, so I'm going to introduce Frank at this point. just lost my glasses. Oh wait, they're in my pocket. All right, the joys of getting older. All right, so Frank Greco is a senior technology consultant and enterprise architect working on cloud and AI and ML tools for developers. He's a Java champion. He's also the chairman of the New York Java SIG, one of the oldest and the very first Java SIG that's in the world, and runs the International Machine Learning for the Enterprise Conference in Europe. Frank is co-author of JSR 381, that's a Java specification request, visual recognition specification, and strong advocate for Java and machine learning. And he's a member of the Null Pointers. So I had the opportunity, the Null Pointers is a band of Java community members. And I actually had the pleasure of first time seeing them at Code One back in 2019. And they started off with Sweet Home Chicago. So I was like hooked right away. Good stuff. And then on a personal note, I've known Frank, I think, going back to the early days of Trenton Computer Festival. I think you presented there. I think that's where I first met you. So it's great that we each have, our corresponding, Java user groups. That yours has been since the beginning, and I'm on year 23. So, yeah, so good stuff. But it's great, great teamwork. So there we go. So,
okay. Thank you, Mike. I can't ask if you can hear me because this is going out over the internet. Okay, let's see. That's over here. Okay, hi everybody. So my talk is about patterns, predictions, and programming, but it's really about machine learning in Java. And please, let's keep this informal. It's the summertime. Like, let's just, if you have a question, just shout it out. It's so I got interested a number of years ago. Like in your career as a software developer or as an engineer or technologist, you're like a surfer, right? You're in the waters and you're looking for what wave should I ride, right? So that's your career. You have to look what's coming. What should I learn and ride? And normally, in your career, you get a chance to ride one big wave, maybe a bunch of small waves, so one big wave. So I actually have been very lucky in my career that I've gone through the Unix and C wave. So I rode that for a long time. Then there was the web and Java, and I rode that for a long time. The New York Java SIG has been around for 27 years, so it's a really long time. So now I see this third wave. I've seen other waves come. It's like Web 3. No, not really. Crypto, no, I don't want that one. And then there's machine learning. It's like, oh, what's this? So as just similar to when I was learning about Java, I started looking at it, and you peel back the onion layer. It's like, wow, there's a lot of stuff here. So when there's a lot of stuff, and it's not just like you're learning a little language or a little tool, it's a lot of stuff. These are things that it's not like you're learning a little software tool. This is something that affects the planet. It affects geopolitics. It doesn't just affect your Java program. It affects geopolitics. That's how big this is. So, and you'll see, hopefully at the end of the talk, you'll see why I think this way, and hopefully you'll believe it as well as I did. And why it doesn't? Here we go. All right, we know that.
Right. Is it possible for you to minimize the camera?
Oh, I can do that.
Oh, it's over here.
Yep.
Okay. Great. Thanks, Chandra. Thanks, Barry.
Whoever.
Whoever, Norbert Wiener here. So So this is back in the 40s. So this professor said, had this nice observation. One of the most interesting things about the world is that it's to be considered to be made up of patterns. So I saw this long time ago when I used to work at Bell Labs, and I thought it was like a fascinating thing. Actually, before I worked at Bell Labs, when I was a graduate student, and I would change it to one of the most interesting aspects of the universe is that it's all about patterns. Everything we do is a pattern. Everything. And back when I was a graduate student, so as Mike mentioned, I'm a musician. So if you were a blues guitarist, and I said, we're going to do a 1-4-5 in the key of A, you immediately know what that means. We can collaborate. If you're a jazz guitarist, I said, we're going to do 2-5-1 in A minor. You immediately know that pattern. So in music, there's all these patterns. So when I was a graduate student, and we're talking about many moons ago in a distant galaxy, so I analyzed melodies from a composer, and I built a probability tree, a tree of probabilities, and then I generated a new song, a new melody based upon those probabilities. So we're talking back in the 80s. I was doing generative AI with music. So it's not new stuff. But my point here is that music has patterns. I worked for the stock exchange, for the New York Stock Exchange, and we were investigating insider trader patterns for illegal trading. We were looking for patterns. We were looking for who were having successful trades and they happen to have the same zip code, like simple patterns like that. So there were patterns. I also got lucky and worked, or maybe unlucky, and I worked for Lehman Brothers. You might remember them in the history books now. And I worked in the fixed income portfolio group, and we were looking for patterns in trading. And we're trying to find out, when the portfolio went up or down, why it did. And we told our customers that we knew why it went up or down. We had, not just a correlation engine, but a causation engine. And we knew why it was happening. Of course, that was a total BS. We didn't know. We just knew that, well, your IBM stock component went up. That's why your portfolio went up. Well, that's not very intelligent, but the customers bought it. Okay. So as programmers, we're very familiar with patterns. And we all know this book, right? Design Patterns. So this book was patterned after a talk at a conference, at an OOPS talk in '87. So this book on patterns was patterned on a talk about pattern languages. Now, that talk was patterned on this book, which is what's called a pattern language, which had nothing to do with software. It was building construction. So we're using patterns in software that was based upon a talk about a pattern language, which was patterned on a book about building construction patterns. And of course, this book, if you don't know, this led to the first wiki, and it influenced Agile. But that book was patterned on things that were done from centuries ago. So whenever you use a decorator pattern in your Java code, it comes from one of these things. So there's patterns all throughout what we do. Now, we use regular expressions. Now, how many people use regular expressions in your code, right? We all do. Regular expressions are all about patterns. They're specifically about text patterns. So they're about text patterns. And as an aside, since we're talking about machine learning and neural networks, so the first artificial neural network was invented in 1943. I guess in the 30s there was mathematical biology, which was math and biology. That's insane. That's crazy. But now it's like, well, maybe not so crazy. So neural networks were invented in 43. Regular expressions, the things that we use every day, were invented to experiment with machine learning. Regular expressions were created to experiment with machine learning back in the 50s. And yet today we use them to check for a URL on email format. So that's all about patterns. So patterns are all around us. Okay, they're in music. Animals use patterns. Certainly my dog knows my patterns and knows when to get me to feed her. In finance, there's patterns. In business, there's patterns. I was briefly an astrophysics student when I was an undergraduate. And in cosmology, there's patterns all over the place. How do stars behave when they get to a certain point where they're kind of pulsating? They're becoming complicated. The chaos index gets higher and higher and higher and finally explodes. So when I was studying that, I said, you know what? That's like software, right? When something becomes so complicated, it explodes, and something simpler comes along and replaces it. I said, wow, that's very similar to cosmology. And you know, as a musician, maybe that's similar to why the Beatles were popular. Why was Elvis popular? Because they followed a period of instability, and we wanted something simpler. So there are patterns all over us and all around us, and there's sports patterns. And you want to find out how to beat your opponent, and whether it's American football or the real football, where you don't use your feet, and not like American football. So patterns are all around us, and it sort of questions our intelligence. So on the left, we have a picture of France, and there's a communications network that hordes of engineers built to make an efficient communications network. On the right is a picture of a slime mold. A slime mold is a single-cell organism. Somebody took a picture of France and put food, I think oatmeal is a favorite food of slime mold, and put it basically where the cities were. And then a time-lapse photography, because slimes don't move very fast, it duplicated the network that humans created. A single-celled organism duplicated the patterns of hordes of humans. So this was, to me, was just fascinating. It's sort of questions, we're talking about artificial intelligence, which is basically mimicking human intelligence. Are we that smart? Are we really that smart? That's interesting. So machine learning is what this talk is all about. It's all about patterns. It's about looking at a data set, looking for patterns, and then either predicting or generating. Right? Either predicting or generating. And I created this little diagram just to make it a little bit clearer, since we're supposed to be the smart people on the planet. So we have artificial intelligence, right, which is simulating human intelligence. Again, you could argue whether humans are intelligent or not, but simulating human intelligence. And there's all kinds of AI things that have been around for decades, right? Expert systems were very popular in the 80s. Knowledge graphs, symbolic AI, linear program. That's AI. Another a subtype of AI is machine learning. And just like the word says, it's where the machines learn. They look at data and they look for patterns. Now, a subset of machine learning is deep learning, and deep learning is a type of machine learning, but it uses GPUs, neural networks, it uses the computing resources of the day. Cloud computing, things like that. Now, within deep learning, there's two basic types. There's generative deep learning, which is commonly called generative AI, right? And that's ChatGPT and others. And then there's predictive, where you're predicting based upon a data set. Like for example, the weather. You're not generating the weather, but you're predicting the weather. And with ChatGPT, you're generating text. So there's two types of deep learning. But in layman terms, people call this AI. Yes, Barry.
So the boundary between deep learning and machine learning, is that only what technologies we're using? Or is there a difference in the architecture of the solution in deep learning? You've got to repeat my question.
Yes, so the question is how different is a subclass deep learning from machine learning? How different are they? From a high level, they're both learning mechanisms. Deep learning typically uses neural networks, where machine learning formerly didn't use neural networks and didn't use things like GPUs, which are necessary for performance. So, but in the press, you'll rarely see the words deep learning. You'll see machine learning, or even worse, you'll just see AI. But again, we are the smart people on the planet, so this is what it really is. Yes, question.
Which one of those levels would you say is doing cognition?
Define cognition.
Well, I was going to contrast it with metacognition. I thought deep learning were models that figured out how they figured something out. Because, for example, I think Facebook research, it does something embarrassing actually to program it to prove a theorem. It had already been proven. This was looked at, said that's not the way we did it. It's probably not even the most efficient method. It's very interesting for you to tell us how we did it. And they said, no, we don't know. So it goes to the machine. So I thought deep learning was a way like to trace through so that it could produce reports and so on.
No, so if you so the question is, if I can paraphrase it, where does cognition occur? Is that a fair paraphrase? I think if you hold that until I explain about what machine learning really is, you might look at cognition differently. But it's a very good question, excellent question. So ML, and we'll call it ML. You know, we're all among friends here. We don't call it deep learning, so we'll call it ML. It's different from the software we've been doing for several decades, right? And the top diagram is that we have data, some data store. We have our model in our heads, how we're going to program something, and we send it to the computer and we get a result. And that's traditional programming. On the bottom, machine learning is different. Now, this is slightly simplified, but you have data, you have a result. How did I get the result? Right? I have data, I have the result. Tell me how to get that. So then the second phase of machine learning is that this is training, creating a model. In other words, you're training. The second phase of a machine learning application is taking the model, now using it in production. I have new data, compare it to the model, what's the result? Right? So you want to come up with a model that represents the data set, and you have new data. Tell me if that's the same as the model. Is this new data the same as the model? So it's a little different from what we're used to.
Trying to visualize
Yeah.
in that comparison you had up there, and you're talking about a result. Where that result come from? Does it come from that data, or come from elsewhere?
So for example, let's say you want to find out if a married couple wants to get a mortgage. You work for a finance company, right? And you say you have all this data, and given this data, this is whether we should give a mortgage to the married couple, right? And there's all kinds of parameters. It could be like 50 parameters. Now new data comes along. It's another new couple, and against that model, should we give the mortgage to this new couple, right? And yeah, okay, Mike.
No, what I was going to say was, I'm thinking about back in the laboratory where you had an instrument that would give you a result, but then based on previous measurements, we had the data and the model based on that, and that result, and then there was a way to do a regression and then try to see if the model can predict. So is that?
It's very similar. You're creating a model. This. If you work in weather or you work in finance, this is the same thing. You're creating models, and then you don't just create a model, but you continually test the model. You're checking the model, right? Like what the weather people do this all the time, constantly refining the model over and over again, and it happens in finance too.
See if any outliers would actually go on that.
Precisely, right. And getting back just to complete the thought on if a couple comes along and they want a mortgage, the model has to be also auditable and interpretable, because you want to be sure, like, okay, why did you or why didn't you give the mortgage to that couple? You have to be able to interpret it and then have a log of that, right? And that's very important. So when a research scientist says we don't know how it works, that's not a good answer. That's not a good answer. Okay, so let's talk about our favorite language and machine learning. So we understand what ML is, but to do ML, you have to learn Python. Well, that's not necessarily true. Okay, I mean, there are reasons. Python's a great language. It's a great language. You know, I worked on Wall Street for a while, and we had languages like R and S+, you know, all the stat packages. They were great for creating models. Like, I wouldn't use C and C++ to do that, but they were great to create models. So Python is great for creating models. And now in production, okay, there might be other languages that are more suitable. But we have to really promote Java for ML. Right? We have to really promote Java for ML. Now, this is something that, you know, a couple of years ago, I think it was at Code 1, and I gave a panel. There was a panel presentation on machine learning, and a colleague of mine at that time, I didn't know, he had a similar talk on another day. And we were both members of the Null Pointers, the band. So we sort of compared notes and we said, you know what, we need to get together and promote Java for machine learning. So we didn't want another JavaScript doomsday scenario. Now, what I mean by that is that here was the web, you know, invented by TBL, Sir Tim. It's this great thing for humanity. Right? The great thing that was invented for humanity, only one thing, you can only program it in JavaScript. So imagine you're in a band and you have to come up with really good music and I give you all a kazoo. You might be a great sax player or a drummer or a bass player or a guitar player, said, I'm sorry, here's a kazoo. So I didn't want that to happen again. I want to say, I'm going to do my damnedest to prevent that from happening again, because I just thought that was like, we cannot all send our creativity through our hearts and our minds through one portal, just in JavaScript. Python's a great language, but there should be many other languages, not just Java. It should be C, Go, you know, all these other languages. But the problem with Java is that there were libraries, but you had to be a C programmer to understand them. You had to understand, like here's a function call with 25 parameters that you're passing to. I said, well, this is not Java, this is C. So they weren't Java friendly. Or you had to know about how GPUs worked. And that's not everybody is like that. So we asked a bunch of companies, you know, were you interested? You know, we went to Oracle, IBM, Amazon. Are you interested in having, you know, using Java for machine learning? And we even visited Twitter before Elon did his thing. And it was 100% across the board. We definitely want Java, you know, machine learning with Java. I mean, they still had their modelers using Python. That's perfectly fine to create the models. But everybody wanted Java. So, you know, my colleague Zoran and I, we said, like, all right, let's come up with an API for machine learning. But we didn't want to boil the ocean. You know, this is the first rule of management, okay? Create something you can deliver. So we said, you know what, we'll do something with visual recognition, because that's fun, do visual recognition. So we have this nice ML layer, but we'll use it for visual recognition. So we created a JSR, and we affectionately call it VisRec for visual recognition, and there's the link for it. And it's a Java-friendly API. So out of the 20 Java APIs for ML, we created what we think is a Java-friendly API. If you're a Java programmer and you look at that API, it says, I feel totally comfortable. Totally comfortable. And we've had a bunch of users use it for demo things. Somebody created a demo to detect TIE fighters from the Millennium Falcon. It was a lot of fun. And they said that the greatest thing about it was like, it was such a simple API. I understood it right away. So it's designed for application developers. It's not designed for data scientists. You know, you hear about like, okay, you have to learn data science to do ML. You have to learn data science. So I've been a professor for a long time, to Barry, right? And we know our students really well. And I know that not even half my students will become data scientists. You know, it's hard enough understanding statistics, right? So they're not gonna learn data science. They might use the models created by the data scientists, and that's how it works on Wall Street, or there are models created by the quants, and the application developers use those models. Similar pattern, right? So there's the high-level architecture. So the thing in like that orangey brown thing at the top, that's the public API. It's a pretty small subset, but we purposely did that to make it very, very simple. But inside, there's actually a generic ML layer if you can create things that are not visual recognition. And just like all JSRs are about APIs, right? They're about APIs, but you have to specify a reference implementation. And we have a reference implementation using deep nets, which is a machine learning library that's open source. And also we had, oops, what just happened? That was weird. And we had Amazon implemented our API. So we were quite happy that Amazon implemented our API. So Frank Liu, L-I-U, took our API and he implemented with the Amazon DGL. So we thought that was really, really cool. Sure.
Are you expecting a lot of variation among the people implementing the, like, are they implementing it in a similar way, or is it possible, you know, some of them be extremely fast compared to others?
So that's a good question. Are there variants in the implementation? Are there any?
Because I understand with machine learning there'd be a lot of variation, so I'm curious.
Well, so that's the thing about the API is that should be static. When I say static, it stays the same. I shouldn't say static, it stays the same. But the implementation, how it's implemented, that's up to the implementer. It could be wildly different from the other implementation, but the API has to remain, because that's the whole reason why we did it. We wanted to write application programs that didn't change when you change the underlying implementation. So they could vary wildly, but that's up to the implementer. Yes, another question.
Here's a question for the board. How easy in general is it to write API wrappers on Java?
How easy is to write API wrappers to?
Java. And what's your wrapper?
Yeah. What are you wrapping?
The Intel OpenCV library within C.
So it matters what you're wrapping. If you're wrapping something that's low level, it could be difficult because that's C, and the Panama, is it Panama? So the Panama API is still early, and that should make your life easier as a Java programmer interfacing with C. It's still early. It's I wouldn't say, you know, jump into it now. It's still early. There's still some things to be worked out, but once that solidifies, we're actually going to be using that to make it easier.
Python library is just CV library is just a wrapper of the OpenCV C library.
So the Python to C interface is very easy, right? As opposed to the Java to C interface, which is not, you know, that's what Project Panama is supposed to fix.
Is that because you think the reference implementation of Python is written in C?
I couldn't answer that question. I don't know the answer to that question. I'm sorry. Okay. So I'll walk through a quick demo, and then I'll run the demo. I wanted to also show some demos with ChatGPT, so maybe I'll do that at the end. So the basic workflow for a machine learning application is that you prep the data, so to make sure you have clean, unbiased data. Then you create the model, right? You train the model. You look for patterns in the data, and then once you have this model, then you put it into production. And then, of course, there's versioning and there's the usual stuff that you do with software. Now, if this was drawn to scale, the data prep part would be the size of this building. So, of course, the sexy part about this is the middle, is like what model you're going to be using, what algorithms, things like that. That's everybody wants to do that. That's almost like the smallest part of a project. It's the data prep part. You have to make sure the data is clean, it's unbiased, there's no outliers. It's harder than you think. That's why data engineering is a really popular job requirement, the description right now. Okay, so here's the problem set. I wanted to train my program to recognize chihuahuas. So I had a data set that I found, the Stanford Dogs data set, and I only used about 870 images, 872 images. So I have all these images, and I use JSR 381 to recognize patterns, and here's the builder pattern for it. The height and width of my images, where the files were on my machine, what's the name of the file that you want to save the model, which is a binary file. How accurate do you want the recognition to be, and just go ahead and do it. That's how simple it was. So then I said, okay, I have a bunch of new images. Once I have the model, right, and it's saved in the file, I have a bunch of new images. I have 3 chihuahuas up there, but I also have a picture of a mushroom. So I have a second program that reads in the model, and it's a neural net image classifiers, our class that we created. And I said, well, there's where the model is, the model file. And once you do that, that's all you have to do. Now then predict, based upon the images, and here's those 4 images that you just saw, are those chihuahuas? And so I get those green arrows there. I get 88% for the first one, 88.68% for Chihuahua 2. For the mushroom, I get 66.4%. And then for the last one, I get 87.79%. So that's pretty good. I mean, it's not fantastic, but it's pretty good for only 872 images. I mean, usually that's a tiny amount. I would never go into production with that low number of images. And when I wrote this program, one of my first ones with JSR, when we had the API finally done, this taught me a lesson. So I said, the mushrooms, it's 66%. That's worse than flipping a coin. Right? It's worse than 50%. So I learned as an application programmer, I didn't have enough data. I didn't train it enough. So when you create a model, you're not done. You have to test your model. And you go through this iterative cycle, constantly test and test and test until you're happy with the accuracy of your model. So I would have to use more data to increase the accuracy.
Or could you use an off-the-shelf model and do, what do they call it? Where you add on. So when you built your model, I didn't see anything about the architecture of the model. Like, is it a CNN model? How many layers?
Yeah, there was an architecture file in that builder that and that in there it specified the parameters of the neural network. Okay, so if you wanted to get started with the JSR, you could screen snap that, or for the people of the future watching this video, that's where you get started. So we used DeepNet's implementation because it was an open source version. The Amazon one, we didn't try, but we worked closely with the gentleman from Amazon, and he had his own demo programs that passed the reference check. So that worked. They implement, right, so they sit underneath us. So here's our API. Exactly. And I think underneath, they have options that if you wanted to use TensorFlow as the lowest level, you can use TensorFlow. But we're using the API.
So you're calling Python?
Yeah, so if you had it like a cloud instance, like a service. All right, so that's JSR 381, VisRec. So we had a lot of fun doing that. So now let's talk about generative AI, which is, I think every single news bulletin I get in my inbox is about generative AI. So stop, enough. Okay, so what do you think the fastest growing programming language for this year is? English. Anyone else? ChatGPT training language? All right, well, we'll see. Yeah, there's a Java program over there. It says, what? Are you kidding me? So we'll see. I have it at the end of the thing. So let's talk about OpenAI and generative AI. So before 2017, machine learning was progressing along. I mean, actually, we started, looking at ML back then, and things were moving along quite slowly. And then all of a sudden, the paper came out, and the name of the paper was "Attention is All You Need." And this is where this thing called a transformer architecture was invented by, I think it's 8 people, right? There's 8 people from Google. So prior to this paper, the way that you trained a model was that you had to get all the data and look at all the data completely before you created a model. It was very sequential. So if you have terabyte of data, you had to process the entire terabyte of data before you actually created a model. And also with language processing, since we're talking about text, it was basically predicting the next word. That was traditional thing. What's the next most probable word in the list? Well, this paper says well, that's not quite. We think that you should assign weights to the words, not just probabilities, but weights, because that word there could be really important relating to the word prior. So don't look at them individually, but look at weights, how they're weighted, their attention. That's why it's called attention is all you need. Where's attention? So that was a novel approach to natural language processing. But the killer thing, especially for us Java developers, is that it was parallelizable. That was the big breakthrough. So it wasn't linear anymore. So you can now do things in parallel. So now you can train models way faster, way faster. So now we know if the 2017, and now it's everything. Things are happening on a daily basis now. I mean, now we're going to Transformer ++ architecture that runs on your computer using threads, hundreds of threads. So this is the paper. This is one of those papers that you read, in school. It said, what are the big papers? Well, it's that paper, this paper. This is one of those papers. And of course, they all left Google. I mean, the last person recently left, I think, a week and a half ago. So they all have their own startup companies, and they're all planning to be super mega wealthy.
They're probably already super wealthy.
Most of their companies are, without going public, they're already worth billions.
Is it easy to summarize in 25 words or less what about it is parallel or can be parallel?
It's just that attention, that the thing about looking at words with attention, it's that's the thing that was parallelizable, as opposed to probabilities and words following another one. So that was a paper that started this craze, especially with ChatGPT. And here are the magic words that you hear a lot, right? You know what a model is, right? It recognizes patterns. A large language model, okay, it's a language model that we've been doing natural language processing for decades, and it just uses a large data set. And we know about generative AI as opposed to predictive AI, and both are equally important, right? It's not like generative AI is that's it. There's predictive AI is also important, but certainly generative AI, because it deals with text and humans, it's very popular. Okay, so we all go to OpenAI.com. That's the company behind ChatGPT, and they have, GPT is the transformer architecture, like I mentioned, and they have pre-trained it. So as opposed to us training the model, it's pre-trained. So that's where GPT comes from. And they have the web app, right? You've all played with, chat.openai.com, right? Or openai.com. That's the web app, right? And that's what, all the people that are not developers use that and think that's ChatGPT. No, that's the web app that uses Chat. And then they have an image, DALL-E is their, actually, I think Midjourney is way better, but they have their image generator. And Whisper is their voice to text. You would think that because they're dealing with text, they probably should work on voice to text. So that's the next thing. You talk, convert it to text and that. So honestly, the ChatGPT is probably their best thing. There's so many other companies have voice to text and image, text to image. I think they're superior, but supposedly GPT-5 is some big breakthrough that's gonna take them to the top again. Okay, so here's all the categories of services that OpenAI has. Okay, we know that it can act like a chat, like a person answering and translating. It can complete text. It can analyze text. It can look at code, Java code, C code, Python code. If DALL-E generates images, and there's the Whisper speech to text. And these two things down here, there's fine-tuning and embeddings. So to me, those are the most interesting aspects. So I'll talk about how do we use ChatGPT on our own docs, right? Suppose you work for a company and you want to create a chatbot on top of your own docs. How do you do it? Well, it's by using fine-tuning or embeddings, and I'll talk about that in more detail. But that, to me, that's the real cool stuff, right? And then here's the web app. So this is ChatGPT, but it's really the web app that talks back to the server. And they created the model. So it's interesting. They created a model based upon like Wikipedia, GitHub, New York Times. So all the intelligence that's in ChatGPT came from that source. You can argue if that's a good place to get intelligence, but that's where they got the basic information.
I've probably seen that there's a lot of like authors now suing because their books were used as source.
Yes.
And that's been coming up in the news over the last week or two. Authors are now suing.
Yeah, so the comment was that there's a lot of authors that are suing OpenAI because their content was used without their permission. So Sarah Silverman is leading that. That's only one of those. The writer strike right now, right? The actor strike. That's another place. So generative AI has been good business for IP lawyers.
It's a business for one lawyer.
Well,
the one who submitted those briefs.
Yeah, that's true. But there's a lot of opportunity. We're in the early days, right? So there's a lot of opportunity for legal precedents to be set, and IP lawyers. This is the golden age of IP lawyerdom right now. We're just getting started. So here's how I learned. When I first came out, I said, I want to write a Java program that talks to ChatGPT. So I knew that a REST API. So I said, let me use a little Bash script. If I can do it through a curl script in Bash, then I know it's academic. I can do it in Java. So the first thing is that I wrote. Well, actually, the first thing I did, I asked ChatGPT, give me a curl script. Please write me a curl script that accesses you to send you a quick message, right? And so it sent me back. It's like, wow, this is cool. It sent me back a curl script. This is amazing. So I tried it, and it didn't work. It's like, wow, this. I thought, what trash software is this? This, how can it be, right? It's supposed to know everything. So I found out that ChatGPT, when it sucked in all the information off the internet, it was done in September 2021. Even its own API, that's what it knew about. So effectively, it didn't know about the latest version to their API. So it was giving me back old information about its API. So I took what they gave me, and then I went to RTFM, right? I read the docs and I got the right parameters and it finally worked. But it was kind of funny, like, okay, it doesn't know anything past September 21. So that I thought that was interesting. But this little curl script works. I mean, you have to get a key from OpenAI. It takes like, I think it took me like 24 hours. You apply and they send you like, well, so I did try it later. I'll show you. I tried it, yeah.
I don't think they'll give it to you unless you give them your phone number.
You mean the key? But you need the key, obviously, like most REST APIs, you need the key to use it. And this is what you get back. So I ran that script, and I just piped it through JQ, which is just a JSON pretty printer. And you get back some metadata, and in red, that's the assist. What did I ask it? What is the joke of the day? Okay. And the joke of the day, there's the joke of the day. So it came back with a message. The role was assistant, and we're going to find out the assistant is ChatGPT, and that's the response. And then I said, okay, well, I'm gonna create the poor man's version of the ChatGPT web app. So I just wrote a little script, and it's just a little loop. Read a string from the user, send it to that curl script, and just print the output. So I mean, it doesn't pretty print it or put in color or anything like that, but it does just as a text. So, tell me a joke about Java. What's a good word for talking? So I asked all these questions, like, I want to invite a speaker. Give me I want to invite people to the next Java user group meeting. Please write something compelling enough. So it works pretty well. And you can even go even further. So here I want you to act like a stand-up comedian, and I'll give you some topics. You should do this, you should do that. And my first request is, I want a humorous take on Java. So it wrote this little jokey thing about Java. So I basically set up ChatGPT. Here's what I want you to do. I want you to behave like this. Here's the context. And here's what I really want. I want a humorous take on Java. So there was a lot of information that I gave to it. Right, and here's another one. So at the top, this is what I said. I said, write a short sci-fi script that describes a conversation describes a conversation. And I gave it this little scenario. It's in the year 2040. There's an Italian boy named Giovanni. He's flying around in a single person quadcopter, and his aliens are attacking him. So it actually wrote this thing, and it was kind of funny to read this. It was kind of pretty cool. So I set up this, I set up ChatGPT. I said, here's what I want you to do. Here's the format. Here's the basic thing, and go. So I basically prompted it, right? So that was pretty cool. So the API for ChatGPT is very simple, and there's the REST. There's the URL for the REST API. It's like a little mini language. You send ChatGPT this language. Here's what you want, and it sends you back the result. Okay, but here's what it really is, and here's what people get confused. People use ChatGPT, and they ask it a question, and it comes back with a wrong answer, and they think it's a search tool, right? They think it's a search tool, and it's really not a search tool, right? A language model is not a search tool. It's not really a search tool. It's an ML program, right? It's really a text pattern recognizer. It's looking for patterns in text. And it says once it has a pattern, it will complete the pattern. So it's a text pattern recognizer and text completion tool. So you train it to recognize patterns, and then you ask it to complete the pattern. Here's a pattern, right? I want you to write a short story. There's this boy's flying in a quadcopter. There's aliens attacking him. So I have the pattern. So I give this pattern to ChatGPT. I say, continue completing that pattern. So you prompt it. So that's where the words completion and prompt come from. So if you ever look at ChatGPT, it is completion and prompt. So what the heck is that? That's what this is. When you talk to ChatGPT, you are prompting it with some patterns. Like, here's the setup. So you prompt it, say, please complete the text pattern. So it's not a search tool, right? The person on the street thinks ChatGPT is a search tool. or it has some intelligence. No, it's language patterns. But there was a thing on 60 Minutes saying like ChatGPT was so intelligent it convinced someone to leave their wife. It's like, okay, if you believe that, you have some serious problems, right? Right. So it's a lot of these stories. It's a text pattern. It's looking at patterns from text, and you prompt it. You start it by prompting it, and you let it complete it. Yeah. So I mean,
that's a story.
exactly right. So it's a text pattern recognition, right?
One funny thing I noticed about text patterns is I study that. So there's an extremely limited amount of data on this. Shove into it. So I said, hey, ChatGPT, let's speak in Latin. And it's really awkward in Latin in the sense that it'll like use a bunch of like, it'll make up words sometimes that or like sometimes mess up my new grammar things. But it's like there's like a very like it follows like a very strange style. It doesn't really, it's grammatically correct. It doesn't really look like anything you'd see if you're like studying maybe like Caesar or Cicero or something like that.
Right, it's imperfect. The comment was about specifically about Latin translation. So, and it comes up with incorrect answers, what are called hallucinations. They're basically mistakes, but they call them hallucinations. It's because the probability, it's like, so there's a parameter in the rest called temperature. And if you set it to be like closer to 1, it's from 0 to 1, it's very like straightforward. If you want it to be more creative, you set it closer to 0, but then it might hallucinate more. So, and also you're dealing with the base foundation model. So if I was building something that was specifically for Latin, I'm going to talk about this a little bit later, I would build a thing that sat on top of the foundation that was trained specifically for that. So don't assume that ChatGPT is the end all for all, because you might want to build it for Latin or for a medical, or for sports or for something else that's tied. So it's a tool. It's a tool. So let's talk about a Java API. So they have a REST API and they offer you the Python API, and everything else is left up to the community. All the other APIs are left up to the community. So there are some Java APIs. So I started to do this myself with ChatGPT 3.0. And it was, writing a REST wrapper, it's not hard. So I did it for 3.0 and I had this nice little thing. It worked fine. And then 3.5 came out and all my code broke. And because their model, they changed their language that you send. So everything just broke. So I said, you know what? I'm not gonna do this again. So I'm gonna use someone's library. So I found a library on GitHub called LittleCat or Little Cat, which I thought was very simple. And here I just wrote, a little forever loop to call ChatGPT. It's very simple, but there's another one called from this gentleman, Theo Canning. So it's a little more complicated. It's not that complicated, but it's a little more complicated than the other one. But his API is more complete. It covers the entire API set from OpenAI. So I would suggest you start with this one. It's a little tricky to use, but it's not that bad. And it's very simple to use. And you give it like if in the middle there, a chat completion request, you tell what model you want it to use. So right now I think there's like 50 models you can use in OpenAI. You can use ChatGPT 2.0, there's a Da Vinci model, there's 3.5, there's GPT-4, there's actually 4 point something, 4.1 I think. And then you get the results and then you display the results. So each model costs different, they have different prices. So ChatGPT 4 is the most expensive model. So if you're doing development, use 3.5 or some other model that's dirt cheap. Like one Sunday, I spent most of one Sunday dealing with 3.5 and writing all kinds of programs with it, and it cost me like 20 cents. So it's dirt cheap. So 4 is not as cheap. Also, another thing that a prompt what you send to one model might not work as well as it to another model. They're different models. So a prompt that worked really well for GPT 3.5 might not work as well for 4. That's another issue. I mean, we're in the early days, so that will be addressed, I'm sure. Mike?
They're charging for their server time?
Pardon me?
OpenAI charging for their server time, like serverless?
Yeah. So if you want, access all the time, like we can try a demo later, and it could time out because I'm using the free version or the cheap version. But if you want guaranteed uptime, of course, yeah. And Rodrigo did me a favor, and I think in 20 minutes he created a Spring Boot version of my program. So Java programmers, you have the API. It's ultra simple to use. So and that's a lot of fun. Now, using it for code. So this is what gentleman asked before. Ask it to write a Java program. So here I changed my curl script to give me a Java program that displays hello world. And there's a Java program in red. I mean, it comes up with some standard prefix that I can't write programs in any programming language. But by the way, here it is. So it's pretty intelligent about code. There's a lot of other LLMs that are just as good at code. I mean, Bard is getting really good at code. Now, how about this one? So I have this prompt, or I'm going to prompt it, and I have a bunch of PDFs in a folder, and I want to get all the text out and put the extracted text in a new file, and each new file is the same name as the old one, but it has 0, 1, 0, 2, 0, 3. So how long would it take you to write that program? In a couple hours. A couple hours. So I asked the question to ChatGPT, and I got that in like 5 seconds. And
Did it properly close the street? That's the only question.
so that's a good.
I don't see a filing block.
But that's a good point.
Close statement there.
That's a good point. What's
I don't see a filing block. That's all I'm saying.
That's a very good point. The first thing you should do as an intelligent person is not to copy, paste this into your laptop and run it.
You're gonna have to Stack Overflow for years.
Look at it, read it, making sure it doesn't do anything nefarious. So I said, I don't like that one, give me another one. And in the next 5 seconds, I got that one. No. Right.
But
So
still no filing. Oh no, that's a chart with research. No, it's good. I'll use it.
So it may not have increased the quality of your work, but it increased the velocity of your work. So just keep that in mind. Yes.
What was the different input when you just said, give me a different one?
Oh, it just says regenerate the completion.
You know what I'm saying? Why did it generate two different?
I just asked it. I just asked it, generate another one, please regenerate another one.
I guess how did it know it? I'm kind of curious how it knew what to create at that point. Okay, curious.
I don't know.
You could probably, after you got the first one, which didn't have really very good try-catch, you could probably say, give me the same thing, but use try-catch.
Well, this is like going to the question is like, how good was the program?
Right.
It's like going to Stack Overflow. It's exactly like going to Stack Overflow.
So does it generate behind the scenes? Does it generate multiple programs and the highest ranked one or something?
The implementation is for OpenAI is completely black box. They won't give you the details how theirs work.
I guess the question I have is, say you ask to get a job role and ask to generate it, and program it. Just have a memory of what it was, right?
So that's a good. Does it have a memory? So when you send a prompt, well, not this, but
Has a window.
has it called a context window? And a context window is just what you sent it, but it used to be fairly small. I think it used to be like 4K. Now it's 16K. And they said like pretty soon it's going to be really big. So that will improve things.
Okay, so it gets sort of a session.
Exactly, right. It has a session, yes. A notion of a session, right. And I sent the same request to Anthropic. So Anthropic's like OpenAI. What is Anthropic's? Claude. It's called Claude. So instead of ChatGPT, Anthropic has Claude. So if you go to their site and you use, so I have it down here, Claude. It's basically the same thing. So it gave me that code. And I went to Google Bard and I asked the same question and it gave me that. So they're getting pretty good at generating code. Okay. But this is what's interesting is the prompt. So remember what prompt is. You're giving a pattern to the large language model. You're prompting it to get started. And then you say complete it. That's where the word prompt and completion come from. So here I create a table with the top 10 most populous cities and give me the city name, population, the current leader, and years in office, and also give me the JSON.
I think that after years it will get so good, they won't get any money for giving programming.
Well, so that's a lot of students that I talk to say that. Like the comment is that will we need programmers in the future? So when I explain to you about embeddings, I think we're gonna need more. I think things are gonna change, like everything else, things change, right? But I think we're gonna need more IT help.
Programmers that know how to prompt engineer GPTs.
There's prompt engineers, and then there's embeddings, and there's fine tuning. They're gonna require new types of IT workers because chatbots. It's not like you're a tech writer and you write something and you forget about it. See you later. I'm going fishing. No, now chatbots are apps. Chatbots have to be deployed like apps. There's dev, testing, there's production, there's maintenance, there's checking. So chatbots are real apps. So it's going to take more people to create these chatbot interfaces. Right? They're applications. It's not just writing text anymore. So the notion of just a tech writer just writing text, that's going to completely change. And it used to be like we're going to create text and we're going to create a chatbot on top of the text. Well, why do we need to do that? We need to create text for both flat text and also for chatbots. So that whole thing is going to change. It needs new types of workers. So the type of workers will change, and we'll probably need more people. But these are cool patterns, prompts that you could send to any one of these LLMs. I thought this was really cool. I want you to act like a Linux terminal. And I want you to behave as if like the bash command line, and here's my first command. And it gave me back as if I typed that at a Linux command line. And then there's some other things that are helpful, like sometimes you get confused, like what does that command do, or what does that regular expression do? And I was a little rusty with JavaFX, and I needed a program, so I said, well, give me a JavaFX program that does this. There's a red button, a blue button, and there's a field over here, and it calls ChatGPT, and it gave me like 99% what I needed. So it's pretty sophisticated. So this notion of prompt engineering, so we all know about SQL, right? People that know SQL, and we have our friends that are the data engineers and SQL engineers that know SQL really well. They know how to create long SQL commands to optimize the performance of the database. We have prompt engineers that know how to fix English text to maximize what we get out of an LLM. So that's what's called prompt engineering, how you design a prompt. And so we had our first, the past year, we had our big flurry of ChatGPT, and the world went crazy. And then things, if you notice, things got a little quiet, right? So why? Because all the programmers like us, we're building tools for the next wave. So you expect like in a few more months, when those tools all come out from everybody, it's like, oh, no, we can do this. So then it'll go do that. So it's a pattern. It's happened before, it's gonna happen again. Okay, so when you're in ChatGPT, we're all developers, don't use the web app. Because the web app is for everyday people, right? We're programmers. Use the playground. So the playground is the REST, is the interface to the REST stuff. You set the REST interface parameters, and then you fire away. So if you notice, there's three things there. There's the system, user, and assistant. So we're the user. ChatGPT is the assistant, and you can send it system messages. So like in the ChatGPT web app, behind the scenes, the system message is I'm sorry you can't read that, but you are a helpful assistant. That's the first message that's sent that you don't see when you use the web app. You are a helpful assistant. If you use the playground, you don't have to say that. You could say you're an unhelpful manager that hated my guts ever since I started this company, and it'll respond like that, right? Or you're a sarcastic comedian. It will respond that way. And you could specify what model you want to use, a more accurate model like GPT-4, which is more expensive, the maximum length of the output coming back, the temperature. I still have to figure out why they call it temperature. Some people call it creativity, right? The closer to 1, it's very uncreative. It's just like following probabilities. As you get the other way, it becomes a little more crazy. You're increasing the chance of hallucinations, but it becomes, oh, that's interesting the way you said that. So when you create a prompt, if you don't just say like, what is Java? I mean, what kind of prompt is that? You're trying to you're giving it an idea how to finish your words. So a prompt has context, right? About like, I want you to behave, like a college professor answering graduate students, or a teacher answering to third grade students. So you tell it how, the context, you give it some example. Here are some examples of what I'm looking for. Here's the question, here's the answer, here's the question, here's the answer. Here's my actual question. And then you might say, I want it in JSON format, or I want it as an HTML page, or I want it as this or that. So there's a structure to your prompt. Yes, Scott?
Can you give it a structured query? It seems like most of the examples I've seen with ChatGPT related to unstructured queries, read more text. Do they accept structured queries, or does that kind of break the language model that they're using?
In what sense? The question is, can you send it structured queries? But structured in what sense?
Describe one that has like Boolean expressions and conditionals or something like you make a structured SQL query, like can you write anything?
I have not tried that, so I don't know the answer to that, Scott. But that'd be an interesting experiment to try.
It seems like it's freeform, and I'm not sure if the freeform is better for the way the model works, or if you could give it a structure.
Right? I would
ask it, why doesn't this program work, or what does this regular expression do? And it does a pretty good job.
Yeah, and so obviously they update their models all the time, and you could try to cross, ChatGPT, OpenAI, and Bard, and Anthropic, and you might get one that's trained better on structured queries. You'd be surprised.
Yeah, that's actually a difference. You said an SQL, a data scientist would write SQL, and now in the future we're going to have prompt engineers writing. There's a big difference. Most of the times, 99 out of 100 times, when I write SQL, it comes back and tells me syntax error. But if I write a prompt, no matter what I write, it's going to come back with something fairly reasonable.
Because you're prompting it, right? Right? You're prompting. It's not like SQL. It's a very rough analogy that I said. You're prompting it how you want it to respond, and it's like, okay, I'll complete it for you, right? But prompt engineering is only one way of programming ChatGPT. So this is what I think is pretty interesting. So there's 3 basic ways. This is the way you structure your prompts. right? Prompt engineering. That's one way, and you can get a lot of mileage out of this. There are people that write these long prompts, and as the context window gets bigger and bigger, in other words, the session memory gets bigger and bigger, you can put more into that.
A lot of people who use it or are new to it don't realize how powerful it is to give it an example.
Exactly.
That really works well.
That's right. The comment is given an example helps the response, helps the completion back. Yes, that's very, very correct. So prompt engineering is one way you can get a lot of mileage out of prompt engineering, but you're not changing the model. You're just giving it prompts, right? The model is still the model. The second thing are embeddings. So embeddings is basically the basis of everything. So ChatGPT is basically a large data store of embeddings. So embeddings are how two things are related. Like for example, if you like music, you say like, well, I like this particular song. Say I like this Metallica song because it is a heavy rock beat. It has certain beats per minute. It's a certain key, and you have these parameters. It's 3 or 4 parameters. Then you say like, well, I like this like jazz tune, Miles Davis tune. Well, the BPM is this, and it's sort of like very slow, and it's more this. So there's 2 types of music, but I compare it against beats per minute, maybe key, maybe I don't know, something else, whether it's a rock beat or not a rock beat. So those parameters, and I'm just using like 3 or 4, but I create numbers out of those, and those numbers are called embeddings. It's basically an array. It's an array of weights, maybe on beats per minute, on the key, on what type of song it is, and that's just 3 parameters. But you can have like 100 parameters. So those arrays are called embeddings. So a large language model is a huge collection of embeddings. So another way of using ChatGPT is creating your own embeddings. So there's an API for creating embeddings. So if you work for a company and your manager says like, it'd be kind of cool to have like a ChatGPT interface to our docs, right? So yeah, it's a good idea. So what you would do is take your docs, send that, you would chunk it. Maybe if it's an HTML, you take like, let me take the H1 and H2 sections, and I'm going to create embeddings for all those texts. So I'm going to create a database, a data store that has embeddings for my docs. So you use a database, and there's embeddings database. There's vector embedding databases. Pretty soon, all databases will have this capability because everybody wants to do it. So you have a database that has embeddings, and then you say like, okay, the user asked this question. You create an embedding, an array for that. Compare that array to what's in the database. Find the nearest one. You do math to it. Find the nearest one. That's the answer. So embeddings there's an API for this. That's another way of using ChatGPT or anyone else. Yes, Barry.
So you say that all the data is really embedded. It sounds like it's hard for them to have put a lot of data in this because you don't just take it and you don't just feed it in raw. You have to massage it before you give it to the machine learning agent. So did they have to do something before they took these reams and reams and reams of books and whatever? Did they have to do something to those? And if they did, how did they do it so quickly? Yeah, so the question is how did OpenAI create the embedding vectors from the internet data? For that much internet? They won't tell you. Oh. Okay. And that's a big complaint. They won't tell you how they did that. But it's a giant data store of embeddings, because obviously machines work on numbers better than words, right? So there has to be number representation of those strings, and then to find out if one is related, there's certain math that you do. It's a matrix math that say like, oh, this one is the next most relevant one. So and a lot of work, I've seen a bunch of YouTube videos on people using Python to create
and embeddings, like a project on their own data store with Python. So that was my next project is do that with Java, the Java API, and then just put it on, so people can learn from it. Now the last thing is fine tuning. So the API, ChatGPT API has what's called fine tuning. That's where you're actually changing the model. Embeddings and prompt engineering, you're not changing the underlying model. Fine tuning is you're actually creating a new model. So you have the base foundation text model that's there, and you might say like, I want to create one for a radiology one, or one for oncology, or one for law, specifically for a certain industry. Well, I need something that sits on top of the foundation model, and I need to train it with a lot of data. So it's going to take a lot more work, but what you get back is something that's fine-tuned for that. So, I mean, there was something in the New York Times where a lawyer, during a case, went up to ChatGPT, had some information from the web interface, and took that text and gave it to the judge, and because it sounded real. And the judge and the other lawyer, the competing lawyer, looked at it and goes, we can't find any of these cases that ChatGPT told that didn't exist. It was just total nonsense. Because it's based upon language. It wasn't designed for law. So if now there are people that are creating fine-tuned models for law and for various things. So over the next few years, we're going to see a bunch of fine-tuned models.
There was one guy, I think it was this past week, he's suing because his name, they merged like two identities. They merged him, he gets the same name as someone else. And the ChatGPT basically merged the two of them and gave results that were basically gibberish about the person. Like they thought the two people were the same people and combined them. So he's suing based on the fact that he's been merged with another individual online.
Yeah, so that's where, so the comment was that there was information, so LLMs were hallucinating. They were combining information and creating false information. And again, these are not search tools. That's what the everyday person thinks they are search tools. They're not search tools. It's text patterns. That's what they are. But they're popular, and then the average person reads this stuff and thinks that it's super intelligent or something. Is no.
I think the average person is still alive.
Yes, it's not alive. Not yet, I guess, but not alive. So you mean the semicolon? So the fastest growing programming language for 2023 is English. Yes, it's English. It's actually human language because all the LLMs, they support other languages other than English. Pardon me?
Vast majority, I guess, is in English.
I don't know, like Alibaba and Huawei, they have LLMs and it's not in English, and they might be bigger than ChatGPT. Okay, so here's one of my, almost the last slide. These are tools. These are tools. You have to learn them because if you want to compete as a programmer, and then you compete all the time, you have to be able to use these tools. Yes,
Scott. The problem that a lot of companies have banned these tools internally.
Yeah, okay, that's a good question.
I'm not saying, it's like some places I would like to learn them, but they said you're not allowed to use them for programming because they're worried about copyright or copyright damage.
That's a good point. So the comment is that some companies have banned the use of these things. They were banned in Europe. They were banned in Italy for a while because when you send data back up to ChatGPT, it uses your data and incorporates that into its model. That breaks GDPR in Europe with privacy laws.
I didn't think it did that.
It did. It did. That's why the ChatGPT.
I also thought Italy still had it banned.
They changed it because ChatGPT now they allow you to check a little thing.
The other issue is it could generate code that it might have copied from someone else, and then now you theoretically are putting production code that was copied from somewhere else.
Well, the Samsung engineers used ChatGPT and they uploaded proprietary information, which is now in the server and it's used. So that probably wasn't a smart thing to do. So if you're a big company and you want to use this stuff, you don't want to use a public model. I want to use a model, but I want it just for us, not for. So if you go to Azure, so Azure, of course, they own half of OpenAI. You can have a private model in Azure, and it's also true with Bard. You can have a private model. Because most companies, I mean, there's public use of LLMs, large language models, but then there's corporate use. To me, the money is in the corporate side, right? If you want to have a startup company, I would deal with the enterprise, anything, whether it's governance, regulation, and how do you, build chatbots for enterprises. That's where the money is, right? Some of the fun stuff is for public, but the money is over here if you want to run a business. So you really have to learn it, and remember, it's increasing the velocity of your production, not necessarily quality. So remember that. It's really important. So and
I'll use it when it can find my null pointer exception. Make it fix my bugs, I'll be there.
you can ask it, what's wrong with this program?
But then you have to upload the whole program, I imagine?
I haven't. I've done portions. Yeah.
Or even just a line that has a syntax error that you can't fix.
Yeah. It's like doing.
It's a lot of Rust. Rust is such a language. Oh my God.
So I've asked it about my code. Can you find this? It's actually pretty good at that.
Yes, it is.
Yeah. So, but what's next? I mean, it's like pair programming, except you're pair programming with someone that's a slash data person. So it's a tool that you're going to be using like an IDE. It might be part of the IDE, right? I would say study about fine tuning and embeddings. Hopefully, I can write a little article on how to do embeddings in Java. That would be a lot of fun. The next generation transformers now are open source LLMs that run on your desktop that get the same performance as ChatGPT. So that's pretty cool. And now we have Java that has you can have hundreds of threads, and you can now train on your machine. The GPUs on our machines now are like crazy good. So there's a lot of interesting things that are coming. The bottom bullets there, see, these are things that are non-technical. They affect economies. Like we think about how does this affect my Java program? This is like, how does this affect like a country? Right? It's like India, much of India, the GDP is based upon support systems and help desks. What if that was replaced by mostly chatbots? It's like, oh. So this has a deep, and it's a long tail. So especially if you're a young programmer, or if you have children that are, should I get into computer science or not? I'm not sure. So ML and AI is affecting not just text, but they're now looking at ML, how it affects low-level operating systems and chip design. Because we've studied how to access data. What are the fastest way to access data? What are the best caches do we have? How do we do that? How do we do this for databases? How do we access things from this? We've done it with a certain mentality. So now they're looking at using machine learning to detect patterns, how we use data, to change how we retrieve data. That's the underlying aspect of how our machines work. And they're seeing increases of 30 to 40%. So we're saying if that's happening now in OS research, and that takes usually 10 years, 5 to 10 years before it hits everyday use. There's a lot of work for young developers, a lot of work. Just as long as you understand what ML is and how it can be used, well, how can it be used for data retrieval, simple data retrieval? They did studies. There's now conferences on ML for operating systems. So it's quite fascinating. So that's my last slide. I hope you found it interesting. Thanks.
I had a question though.
Sure.
About your JSR.
Yes.
Now, I understand that the JSR is just the API.
Correct.
But do any of the implementations GPUs.
So the question is, does for VisRec for JSR 381 do any implementations use GPUs? So right now the Amazon implementation uses TensorFlow, which does use GPUs.
Oh.
The deep nets doesn't yet, but it will.
Because I think that's one of the big reasons why Java never caught up for ML. They didn't want to interface to a GPU. They wanted to keep it CPU agnostic and write once run anywhere except if it's a GPU.
Right. So Project Panama addresses that issue. Yeah.
Well, okay. Yeah,
Yeah.
there's a lot more to just a C API for writing, the interfaces CUDA, or there's other ones.
Exactly right. Exactly right. Totally agree. So another question? Yes. How does it recognize the patterns? How does it detect patterns in what you send to it, or so remember what I said about embeddings? So it takes what you send it creates embeddings out of the text that you send it, basically numbers or vectors, right? And then it compares those vectors, those embeddings, against the ones that it has in its data store to find, and it does it through, it uses matrix manipulation to find the closest one numerically, and that's your answer. As far as I know, there isn't. I thought it'd be useful to have one for prompting, because now that we have different companies have the prompt APIs, but I haven't seen one yet. There should be a JSR for that stuff. I mean, the more Java people use ML, the better, I think.
What is that? I noticed you had that like chatbots. I think it was last year Microsoft put its chatbot AI on Twitter. And do you know the story I'm talking about? The one, what do you tell it?
No, go ahead, Scott.
It's the one within 24 hours. So it learned from Twitter. And within 24 hours, how do I put this in polite conversation? It became bad.
Yeah.
It said some within, like it started off like friendly, hello, everything's going great. And then as it learned and as people talked to it, like within an hour, it was saying some pretty
nasty things.
Like, I mean, you've been on Twitter, so.
Yeah, so, right. So it learns from what humans put into it, right? So I mean, this happened years ago before we had the transformer architecture. Microsoft had a chatbot to put out there, and it basically became foul language. It became quite foul in a short period of time.
Training on Twitter.
It said some pretty inappropriate, horrible things about different groups of people. Is all it was.
Yeah,
But
it's
again, if you've been on Twitter, that's normal Twitter.
yes, normal. Yeah, so this is just a tool, and it can be used for evil as well as for good, right? There's people who wear the white hats and people wear the black hats. There's actually now a LLM that's specifically for the black hats, which is really sad. It's specifically for people to create hacks. Generate a program that where I can attack a Cisco router, and it's here you go. It's like, okay. So it's an interesting world we're entering. Which means there's opportunity for people that are on the good side to battle the bad guys, like an arms race, right? And that will happen. That means if you're in security business, you'll have work for the rest of your life.
So there's the stories about like AI generating voices of the person, people and scanning people, like calling up as your child, saying $20 or something.
That's the next thing too. Like there's companies like Synthesia, and there's one where you can train. It only needs 3 seconds of your voice and to create basically a model of your voice, and then you give it text that you want to say. It's like, wow, that was pretty darn good.
Or I could give it 3 seconds. There he is. Tell him.
Yeah. So it is scary, and how people watermark these stuff. I mean, this is all brand new, so it's opportunity for us, for people like us. Like, how do you watermark this stuff? Yeah. So this is, as I said, this is when I looked at this as what wave do I want to ride. This one has a long tail with so many aspects to it, and it's not just like learning an API or something. So it's pretty cool.
On this learning algorithm program with the blog, so is it more like each one has a co-pilot or using AI
You mean in terms of what?
to learn what kind of things
Oh, so I mean, what should be your next step? You mean? Okay, that's a good question. The first thing I would learn is go to the sandbox, or play around with that, and then write a Java program using that API. I mean, it took me like 15 minutes to get it from GitHub and write a program, and then incorporate it into a server. Put it in Spring Boot or something like that, so you're accessing it, just to get a feel on how you give it prompts, right? And you have to get past this hurdle that it's not a search tool. It's not a search tool, right? It's like once you cross that barrier, it's just recognizing patterns, and you start it by prompting it, and it completes it for you. Once you get that done, I'm sure you'll find someone that says, like, we need to build a chatbot interface. Could you do that? I think that would be a meaty project to do, and where you'd learn a lot. Okay, well, thanks again.
Thank you, Frank. If we can put up the other. So stick around. We have our giveaway for a license of IntelliJ IDEA. So thank you. So yeah, I just wanted to mention, you had mentioned IDEs. JetBrains just came out with their AI assistant. That's going to be limited to the IntelliJ-based IDEs and I think the .NET tools. But it's just all kind of breaking and brand new. So, but that's something to look for. So to wrap things up, just wanted to go over a couple of things, and then we'll have everybody a chance to snap the picture of our QR code for the raffle. So, so we're gonna the upcoming events. We are gonna have a summer break next month. Okay, so but in September we're gonna have a couple of things going on. First of all, there is a Java and Education event / I think meeting, and maybe Barry can shed some more light on that. But it's so but it's sponsored by Oracle, and this will be at BNY Mellon in New York. Heather Von Cura will be out for this, and I think it is gonna be an event for teachers. And also, I think there's going to be a presentation by someone from Oracle on the likes of Brian Getz or somebody like that. So we're trying to get some more information and get things fleshed out. New York's going to be involved, so I think this is really cool. So I think this is September 12th, 13th, September 12th, 14th. Those dates right there. But we'll have our own September meeting, and more about that in a bit. Oracle Cloud World is in September. Java 1 is changing. So yes, that's what I mean. But there has already been some confirmation that they're going to have some regional events. So more on that, okay? But their Cloud World still will go on in Las Vegas in mid-September. I think that's 100%, yes. So Eclipse Con in October, it's in Germany if you want to go out there. JCon World is virtual in November. Now they had their in-person event last month. That was also in Germany, I believe. Jakarta 1 is on December 5th. I'm happy to be on the program committee again for that one. And I'm sure there are a couple others in between I may have missed, but it gives you an idea of what's going on. All right, so what's coming up for us? As I mentioned, we're taking a summer break next month, and we look forward to seeing you September for the Java and Education possibly event with Oracle, and on September 19th We're happy to have Gerrit Grunwald from Azul and Ivar Grimstad from the Eclipse Foundation to be here and to give two separate talks. Actually, I just learned that today. They sent us their choice of talks we can select, and we'll have the website updated for that. In October, Matt Rabel from Okta is making the tri-state visit. He'll be in Philly on the 17th, and then he'll be with us on the 18th, and then in New York on the 19th. And we have selected OAuth for Java developers, and you guys are leaning towards the micro front ends, I believe, talk. Is that confirmed now? Yes. Okay, so. And then we have November and December open at the moment. We are, trying to work with some other folks to come visit with us, but, we'll have to work on getting that set up. So, so tonight is also, this is a popular night tonight. The Houston Jug is actually having Otavio Santana and Bruno Sousa talk about simplifying Java mastery. This is all remote, and I think some other Java user groups are invited to that. And then also Atlanta has their presentation tonight with Joseph Kosovar and Ari Waller. On Thursday, Kansas City Jug has Deshaun Carter. On the 26th, New York has Olivier Popeny. Did I pronounce that correctly? Okay, close enough. So that's in New York, right? That's in person, right? Yes. Okay. You can go to the website and find out. And then the Atlanta folks have Melissa McKay from JFrog, and she'll be talking on Tuesday, August 15th. So they have. I just gave you tonight's and then next month's. So, and that's all I have. Oh yeah, and then September, the Boston/New England Jug. They have their presentation. And I wanted to give special mention to Chicago because Chicago is one of our friends of the Garden State Java Group. They had their meeting last Wednesday, so with Simon Martinelli. All right, so take out your iPhones or Samsungs, and if you're interested in submitting your name for the raffle, it's a BlackBerry, they still make those? I had one of those about 15 years ago. So, any questions for us? Yes. No. Okay. Yeah. Yes. The equipment you see here will be over in New York. So, yeah. So.
Didn't I put that on YouTube or on the Eventbrite page?
When you sign up on Eventbrite, you'll see that.
Okay. So something that's crossed my mind more recently, and just want to get an idea how people feel. Some Java groups have a predefined time, an earlier time to go have pizza or other kinds of snacks before the meeting starts. Like at in our case, it would be 5:30. So people can come at 5:30, have something to eat, and network beforehand. Now I know it's more difficult for us being in the suburbs as opposed to the like New York City or Philly. I don't know if people would be able to make it here by 5:30. I don't know. What thoughts on that? Or just keep things the way they are? Okay. Okay. No, like I said, it was something that crossed my mind, and I thought maybe see how people felt about that. But I get it. I know. So, okay. Everybody's had a chance to take the pictures over there. Okay, those are rules. Okay.
Let's do it offline.
You want to do it offline? Okay, that sounds good. We can run the. So we will run the. Our random number generator, and the winner will be emailed with a PDF coupon that needs to be redeemed by a certain day. So, other than that, any other questions for us, or I forgot to mention, we had a special guest here tonight. He had to leave early, and I failed to acknowledge him. It was Sharat Chander from Oracle. I think he leads the DevRel team out there. So he was here. He had to leave early. And of course, I didn't get a chance to do the hashtag Chandra Gunter sighting. He's one of our directors. So we happen to actually have all 4 directors here tonight, which, yeah, he left too. He had to leave early as well. So, but I failed to mention them earlier today. But anyway, so thanks for coming. So, but yeah, oh, excuse me. So, but yeah, it was for me. It was the first time I met him in person. I've known him on Twitter and via email and things, but it was a real treat for me to meet him today. So with that, thank you very much. It is that time of day to celebrate with a nice, 16-ounce, your favorite craft beer. In my case, I love craft beer. So anyway, thanks for coming out on the summer night. We appreciate your support, and we'll see you in September. So we look for some of my email updates. So.